Hello, everybody. Welcome back. This is Lesson 6, Properties of Ionic Compounds. Before we start, though, I noticed in the comments section of one of the other videos that someone noticed that these are salt crystals. And this is actually what salt looks like under a microscope. And I waited until today to kind of bring that up because it goes into what we were talking about later. So, in the last video, we covered dot structures for the ionic compounds. Basically, just a puzzle of putting all the positives and negatives near each other. And today, we're going to spend some time going over properties of ionic compounds. So, now that you know how they're made, what they're made of, what are some other properties of them? So, again, this should be kind of knowledge by everybody right now. What is an ionic bond? Again, it occurs between a metal and a nonmetal. So that's one of the most important parts. And then the transfer of electrons. So the electron from a metal is stolen by a nonmetal. Remember, nonmetals are more electronegative because they have a greater attraction for these electrons. The highly electronegative nonmetal steals that electron and gains it. So when a nonmetal gains an electron, it becomes negative, and we call that an ion, an anion. And when the metal loses an electron, it becomes positive. We call that a cation. So again, this should be reviewed. And here are some lovely pictures about ionic bonds. Take a second, absorb it, like it, laugh, don't laugh. Okay, I think they're pretty funny. Anyway, again, this is more review. What is an ionic compound? It's a compound composed of anions and cations. Remember, these are your negative nonmetals, and these are your positive metals. And again, even though you have negative and positive stuff, the overall compound is neutral because the number of positive stuff has to equal the number of negative stuff. So that's why you have, NaCl, because we have one Na because it's positive one Cl, which is minus one, plus one, minus one cancels out neutral. If you look at lithium 2 oxide, you have two lithiums because lithium has a plus one charge, oxygen has a minus two charge. When you crisscross that, now you have two positive ones, which gives you a total of positive two, one negative two, which gives you a total of negative two, boom, neutral. Again, this part is also review. So getting into some of the new stuff, one of the first things about ionic compounds is that they have a crystalline structure. So what that means is that they have these repeating three-dimensional patterns. They're very, very highly organized. So here is a great example of salt. Now you have these smaller purple circles, and you have the bigger green ones. Knowing what you know about NaCl, what do you think the purple one is? What do you think the green one is? Look at the size and think about what you know about the formation of salt. So you should have said that the purple is sodium and the green is chlorine. Remember, the green is bigger, so it means it gained an electron. Purple is smaller, it lost an electron. And again, you have positive, minus, just kind of like this, very highly organized. So they kind of build these 3D crystalline structures. And that is what this is showing here, the 3D crystalline structure of salt. So that's what it actually looks like under a microscope. Okay. So here are some other examples of ionic compounds. Again, here's your metal, your nonmetal. This is an ionic compound because we haven't talked about this yet, but this part is what we call a polyatomic ion. So these four elements, when bound together, have a charge, and then bonds with Ca, just like a normal ionic bond would. And this is a super complicated one, but again, pretty cool examples. Now, one of the other important properties is they have very high boiling and melting points. So the attractions between the negatives and positives of all these ions are very, 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 very strong. Ionic bonds are one of the strongest types of bonds. So if you wanted to pull apart this molecule, you need a lot of energy to do that. So you can break this up, but you need a lot of energy to kind of pull these things apart. And that's where high melting and boiling point comes in. You need a lot of this energy. And we talk about temperature later on. We'll talk about how temperature is just average kinetic energy at the speed of the molecules. So again, high melting point, high boiling point, because the attractions are very, very strong. So if you have high melting point, high boiling point, that means you have strong attractions. If you have low melting point and boiling point, that means weak attractions. And those are generally your covalent bonds. So ionic bonds, high melting point, high boiling point, very, very strong attractions. Another property is that they are soluble in water. And so these ionic compounds can dissociate into their ions. So what this means is if we have, let's say, CaF2, when it gets put in water, it breaks up into its Ca ion, and it breaks up into the two F ions. So once all the water is gone, it can kind of reformulate and make that compound again. But the ions themselves, that's what dissociation is. It's breaking up into its ions. Again, you see this here. You have that solid calcium fluoride, and then the ions floating around. Now, because you have these floating ions, these free floating ions, you can conduct electricity. So electricity is all it is the flow of electrons. So if electrons are able to kind of flow freely, then electricity can be conducted. So that's why ionic compounds can conduct electricity when they're melted or in their dissolved / dissociated form in water. So again, if you see dissolved in water, you'll see it as AQ. So if something is able to, if it's dissolved in water, these ions can kind of flow wherever they want to. If the ions can flow freely, that's what allows electricity to happen. Again, those electrons can flow, but only in melted or dissolved in water. Okay, so that's basically it for the content. Let's just go ahead and try 3 questions to kind of sum everything up. So question 1, what sample of matter has particles arranged in a crystalline structure? So crystalline structure, you should think ionic compound. Again, that is a metal and a non-metal. And that gives you a C and D. But then a crystalline structure, the other part is, well, it has to be an ionic solid. Remember, if it's a liquid, the ions are kind of flowing freely, they can do whatever they want. So the crystalline structure is talking about solids. So that's why it is a D. And if you even think back to, this picture, here's a solid ionic compound. These ions, they're stuck where they are. They cannot flow wherever they want. So that's why a solid ionic compound does not conduct electricity. But when it's dissociated, it can. Okay. Question 2. What type of liquid can conduct electricity in the liquid phase, but not in the solid phase? So again, you should think ionic. And we haven't talked about the other stuff yet, but even when we do, ionic compounds in a solid cannot do anything. But if it is melted, so if it's a liquid, or if it's dissolved in water, AQ, then you have those free flowing ions. So free flowing ions is the most important part. Okay. Lastly, question is which of the following solids has the highest melting point? Again, right now, the highest melting point are things that are ionic, that is a metal and a non-metal. And so the only option with a metal and a non-metal is B. So again, those are the types of questions that you'll see with ionic properties. As long as you just kind of remember that they have very strong attractions, that tells you need high melting point, that tells you a lot of stuff about it. So that's basically it. And the next video will be the last video of the unit, the last content video of the unit, and we'll cover metallic bonds. That's it. Bye.